In this video, we're going to talk about the relationship between empirical formula and percent composition, and how to obtain the percent composition by mass of a compound from its empirical formula. So just to review, the empirical formula is the simplest formula for a compound that maintains the proper ratio of elements. So for example, we have the molecular formula, which gives us the exact number of atoms in a molecule. So we have something like H2O, or C2H4. And then the empirical formula for these, for H2O, it's the same. We can't simplify the ratio of 2:1 hydrogen to oxygen any further. For C2H4, we can simplify that down to CH2. So the ratio of C to H is identical between the two, but the empirical formula is the simplified version, if possible, for the ratio of elements in the molecular formula. So let's look a little closer at H2O. So let's say we have one molecule of H2O. That means we have 2 atoms of hydrogen and 1 atom of oxygen. Similarly, let's say we had 1 mole of water. That would mean we have 2 moles of hydrogen atoms and 1 mole of oxygen atoms in 1 mole of water. So notice something that's consistent between whether we're looking at 1 molecule or 1 mole of water. We have a 2:1 ratio of hydrogen to oxygen. In 1 molecule, we have twice as many hydrogen atoms as oxygen atoms. In 1 mole of water, we have twice as many moles of hydrogen atoms as oxygen atoms. And from this ratio of atoms of different elements in a molecule or a mole of a substance, we can obtain the percent composition by mass. So what we're going to be doing mathematically is going from the molecular formula and obtaining the empirical formula, and from that getting the percent composition by mass. So it's a 2-step process. I have a previous video on going from molecular formula to empirical formula. So in this video, we're going to focus on obtaining the percent composition. And to do that, we're going to look at ethylene. And ethylene has the molecular formula C2H4. As we saw above, the empirical formula for C2H4 is CH2. So that was step 1, obtaining the empirical formula. And now we're going to see how to calculate the percent composition. And the percent composition will be for ethylene, but we're going to be using the empirical formula to calculate it. But it will be identical for either C2H4 or CH2 because the percent composition is consistent because it's based on the ratio of carbon atoms to hydrogen atoms. So let's say we have 1 mole of C2H4, and we want to know the percent composition of carbon and hydrogen within ethylene. And so this is going to have the same percent composition as 1 mole of CH2. And here we're just using moles. We could say molecules, but we're going to be using the molar mass in just a minute. And we know that this 2:1 ratio, which is critical for finding the percent composition, the ratio is the same whether we're looking at molecules or moles. So we have 1 mole of CH2. We're going to calculate the mass of carbon and the mass of hydrogen within 1 mole of CH2. So let's look at the mass of carbon. So we know we have 1 mole of carbon within 1 mole of CH2. And we're going to multiply that by the molar mass of carbon, which is obtained from the periodic table, and that's 12.011 grams of carbon per 1 mole of carbon. Moles carbon cancel, and we get a mass of 12.011 grams of carbon. Now we're going to do the mass of hydrogen within 1 mole of CH2. And we know in 1 mole of CH2 there's going to be 2 moles of hydrogen atoms because of this subscript 2 on the hydrogen. So 2 moles of hydrogen we're going to multiply by the molar mass of hydrogen, 1.0079 grams hydrogen per mole. And that gives us 2.0158 grams of hydrogen. So these are the individual weights of all the carbon atoms and all the hydrogen atoms in 1 mole of CH2. So in 1 mole of CH2 we have 12.011 grams of carbon and 2.0158 grams of hydrogen. So adding these values together gives us the total mass of CH2, that is 1 mole of CH2. So 12.011 grams plus 2.0158 grams gives us 14.0268 grams. And so that is our total mass for 1 mole of CH2. And so what we're looking for is percent mass of, for each carbon and hydrogen. So percent mass for carbon, to determine the percent composition by weight for each element, we're going to divide the mass of carbon by the total mass, and then the mass of hydrogen atoms by the total mass of 1 mole of CH2. So 12.011 grams of carbon is how much mass of the total mass is carbon, over 14.0268 grams of CH2. Multiply this by 100% because we want to get a percent, and we get 85.629% carbon. Now let's calculate the percent mass of hydrogen. We know that there's 2.0158 grams of hydrogen atoms, and the total mass is 14.0268 grams of CH2. Multiply that by 100% to get a percentage, and we get 14.371% hydrogen atoms. And so these are the percent mass of carbon and percent mass of hydrogen within CH2. And of course, CH2, the percent composition, is the same as C2H4 percent composition. So C2H4, ethylene, which is what we started with, has a percent composition of 85.629% carbon and 14.371% hydrogen by weight. Even though we used CH2 to calculate the percent composition, we know that both of these, CH2 and C2H4, have a 1:2 ratio of carbon to hydrogen, and because of that we know that the percent composition by weight of each element will be the same whether we use the molecular formula or the empirical formula, but definitely the empirical formula will give smaller masses and will make the calculation much easier, and in the end will give the same percentages, which is what we're aiming for. So to review, we're going to use the empirical formula, which is the simplest formula that maintains the ratio of elements in a compound. If we're given the molecular formula, we'll find the empirical formula and then calculate the percent composition by element. And to do that, we're going to calculate the mass of each kind of element. So in ethylene, we have carbon and hydrogen. So we're going to calculate the mass of carbon in 1 mole of ethylene, simplified to CH2, empirical formula. We obtained those masses of carbon and hydrogen, added them together to get the total mass, and then divided the individual masses of carbon and hydrogen within ethylene by the total mass we just calculated, multiplied by 100%, and we got our percent composition by mass for carbon and percent composition by mass for hydrogen.